let a is equals to in a closed bracket minus 1 to 1. So we are given a equals to close in a closed bracket minus 1 to 1. Then discuss whether the following functions defined on a are 1 1 onto or bisective. So we have to show whether the function is 1 1 onto or bisective, and function is defined on a. So here for 1 1 we need to consider f of x1 is equals to f of x2. It means that we can write x1 by 2 is equals to x2 by 2, that is x1 equals to x2. So we can see x1 is equals to x2, hence it is 1 1. So for 1 1 we need to consider f of x1 equals to f of x2, and we have to show whether x1 equals to x2 or not. We can see x1 is equals to x2 here, so the function is 1 1. For onto we have to consider f of x as y. So y will be x by 2. We have to convert this to x. So x equals to 2y. So we can see the if we consider the value of y as 1, so we will get x as 2, which is does not belongs to capital A. So this is not onto function. So this is not a onto function. The function is 1 1 but not onto. Let's consider second function, that is g of x equals to mod x. So for that we need to consider g of x1 equals to g of x2. So we can write mod of x1 equals to mod of x2. So we can write x1 is equals to plus minus x2, because we are taking x1 and x2 outside the mod. So we are deleting mod, so we will get x1 equals to plus minus x2. So here we can clearly see, that this is not a 1 1. This is not a 1 1 function, because x1 is not equals to x2. X1 is equals to plus or minus x2. So it is not 1 1. So for onto function we need to consider g of x as y. So y will be mod x and x will be plus or minus y. Here y is the output value and x is the input value for the function g of x equals to mod x. So here we can clearly see, if x is the input, then we will get two output. One is plus y and second one is minus y. So here, so it does not belongs to a. So it is not a onto function, not a onto function. Let's talk about h of x, which is equals to x mod x. So we can consider h of x1 is equals to h of x2. So we can write x1 into mod of x1 equals to x2 into mod of x2, and x1 mod of x2, x1 equals to x2 mod of x2. This is equal for different condition. Okay, if we consider x1 comma x2 is greater than or equals to 0, then we can write x1 square equals to x2 square. Okay, that is x1 equals to x2. For x1 comma x2 is greater than 0, and if x1 comma x2 is less than 0, both less than 0, then we can also write x1 square equals to x2 square, that is x1 equals to x2. So h of x1 is a 1 1 function. So h of x is a 1 1 function. For onto we need to consider h of x as a y. So y will be x of mod x. So for different condition we can write y is equals to x square if x is greater than 0 or equals to 0, and y equals to minus x square if x is less than 0. X is less than 0. So we can see x is greater than 0, this interval will be 0 comma 1, 0 to 1, and for x is less than 0 it will be minus 1 to 0. It means that it is verified for the given interval, that is a equals to minus 1 to 1. So we can say that given function, that is h of x, is a onto function, because y equals to x square it is defined in the interval only, and y equals to minus x square as well, it is also defined in the interval only for x is less than or equals to 0, or x is greater than or equals to 0. So h of x is a 1 1 and onto function, hence it is bijective function. So h of x is a bijective function. Let's talk about k of x is equals to x square. So for 1 1 we need to write k of x1 is equals to k of x2. So it will be x1 square is equals to x2 square. So from here we can clearly say that it is not a 1 1 function. If x1 comma x2 is greater than 0, then it is 1 1, or x1 comma x2 is less than 0, then it is 1 1. But for opposite signs of x1 and x2, it is not a 1 1 function. So it is not a 1 1. So we can write x1 is equals to plus or minus x2. For onto function, we need to write k of x is equals to y. So y is equals to x square. So we can write x is equals to plus or minus root y. So we are getting plus or minus root y, which does not belongs to a. Why? Because if we take y is equals to minus 1, then x will become imaginary. X will be belongs to imaginary, which is not belongs to capital A. Hence, it is not a onto function. So k of x equals to x square is neither on 1 1 nor onto.